this is Himabindu from the Department of CSIT. So today in this video, I would like to explain about the concept called ambiguity. So ambiguity in the context-free grammar. So what is meant by context-free grammar and what are the derivations of strings from the context-free grammar we already discussed. So in this video, I would like to explain about the ambiguity in the context-free grammar. So what is meant by ambiguity in grammar? So ambiguity is nothing but a grammar is said to be an ambiguity. So if there exists more than one or leftmost derivations. So here we already discussed about the leftmost derivations and rightmost derivations in the context-free grammar. So we have two types of derivations. One is leftmost and rightmost, and how to derive a string in leftmost derivation and rightmost derivation we already discussed in the previous video. And here we have in context-free grammar, if we have one or more leftmost derivations or one or more rightmost derivations or one or more past trees. So here the past tree is nothing but a tree, derivation tree. So here the derivations tree also have two types. One is left derivation tree and right derivation tree. So we already discussed about this derivation tree also. So in the grammar, if suppose in the context-free grammar is having the string derivations, one or more leftmost derivations or rightmost derivations, or we can form with the string derivation, we can form the two or more past trees. That is the grammar called the ambiguity in the grammar. So this grammar, if the grammar is not ambiguous, then it is called unambiguous. So obviously, so the grammar which is not ambiguous, we can say that it is a unambiguous grammar. And if the grammar is having has ambiguity, then it is not good for the compiler designing. So if we want to design the with the compiler design with this context-free grammar, so there should not be a ambiguity in that grammar. So we have to check whether there is a ambiguity in the grammar or not to design the compiler. And no method can automatically detect and remove the ambiguity. So there is no method to detect or remove the ambiguity in the grammar. So what is the solution for this one? In the sense, we have to remove the ambiguity. So removing the ambiguity by rewriting the grammar. So we have to rewrite the grammar to remove the ambiguity in the grammar. So what are the ambiguity and how to derive leftmost derivations or rightmost derivations from the string with the ambiguity? We'll check. So here is the example. So we have taken the production rules of E and E tends to, these are the production rules. So let me write this grammar for this one. So in the grammar via phi tuple, what are the phi tuple in the sense? So V, T and G, production P and starting symbol. So these are the four tuple notation. So for the grammar. So here if you take this production rules for this, what is the grammar? So V is nothing but it is having the only capital symbols. Those are nothing but non-terminals. So the non-terminals are only E. So and what are the terminals? So here only one single terminal is there, that is ID. And what are the production rules? So these are all the production rules. And next, start symbol. So start symbol is, which is having the first production is having the E. From E it is starting. So E is the start symbol. So this is how we have to define a four tuple for the given grammar. And here, after this one, we have to check whether this grammar is having the ambiguity or not. So by deriving a string, so by deriving the string from this grammar, we can say that it is having the ambiguity or not. So let's check this ambiguity with a simple example. So here we have taken this string. So string ID plus ID plus ID minus I. So this is the string. We have to derive this string with this production rule. So how? We'll see. So let's take the start symbol E. E tends to E plus E. So if you take the leftmost derivation, so leftmost derivation is nothing but we have to change the leftmost symbols. So leftmost non-terminals, we have to replace it with the terminal symbols. So here the leftmost derivation, it is having, we can say that ID and Here, after this one, we have only one non-terminal is there. So what is that a non-terminal? We have to replace this one. So ID, and here we have to replace it with, we require minus symbol. So is there any production rule with the minus symbol? We have to replace it with the E minus E. So that is E tends to E minus E. And here also what we have substituted, E tends to ID. So after this one, so we have to substitute the, what is the next leftmost derivation, leftmost non-terminal symbol. We have to replace it with the E tends to ID. And here ID, and again we require E tends to ID to derive this string. So ID plus ID minus ID. So this is the string what we have derived in the leftmost derivation. So let me draw this derivation tree, and here we have taken E, E plus E. So this is the first step. This is the root node. So deriving tree, first we have to take the start symbol and we have to derive the production rules. And here first step, next step what we have done, ID is replaced, and next this E is replaced with E minus E. And after this ID is replaced, and again this ID is E is replaced. So after deriving this derivation tree, we have to read the string from left to right. So what we have, the input string. So ID plus ID minus ID. So this is the string what we have got from this derivation. So this is the leftmost derivation. And here let me write another derivation also. So here we have to take this E plus E minus E. We will take this production rule. So E minus E we will take. So here in the leftmost derivation tree, again we will form one more derivation tree, with this simple. So here we can write the rightmost derivation. So here rightmost derivation. So here E is replaced with ID, and after that this E is replaced with E plus E. And here we will write E tends to ID, and here E tends to ID. So after deriving the string, we will read by left to right. So what is the input string? So ID plus ID minus ID. So this is the rightmost derivation. So here this is the rightmost derivation and leftmost derivation. So with the leftmost derivations, we can form one more derivation tree. So with the same input string, how we can see. So E tends to E plus E. So here E tends to E minus E we will take, and here, so after this one E plus E we are writing, and this is the leftmost derivation. So this is also leftmost derivation, and this is also leftmost derivation. So in the leftmost derivation, we have to substitute this ID, and this is the leftmost non-terminal symbol. So we have to replace this E, and after this one, we have to replace the another leftmost non-terminal. So this is the ID, and after finishing all the leftmost symbols, we have to move from left to right. We have to move. So here ID. So after this one, we will get the input string. So input string is ID plus ID minus ID. So for the same input string, we formed the two leftmost derivations. So here with the same single input string, we form the two leftmost derivation trees. So we can say that this grammar contains the ambiguity. So why? Because we have the two leftmost derivations for the same input string. So with this statement, we can say that this grammar contains the ambiguity. And let's check for the another example. And here we have taken the S tends to A A capital S B. So let me write the grammar for this one. What is the grammar contains? V terminals and production rules and stat symbol. So what is the V? So what are the capital letters which are involved in this grammar? So what are the capital letters? Only one capital letter S is there. That is the non-terminal. And what are the terminal symbols? So what are the terminal symbols? A, B, comma, epsilon. So these are the non-terminals. And what is the production rules? What we have? And what is the stat state? So stat state is S. So this is about the grammar for the given context-free grammar. So let's check this grammar contains ambiguity or not for the input string A, B, B. So this is the input string. For this input string, if you have a two or more leftmost derivation, we can say that it is an ambiguity in the grammar. So let's check for the input string A, B, B. And for first step, what we have to do? We have to take the production rule S, A, S, B. So let me write the derivation first. After that, we can convert that to a tree, derivation tree. So here we require A, B, B. And for this one, what we have to do? So in the leftmost derivations, so first there is a non-terminal, only first there is a terminal and next one is a non-terminal. So we have to replace this non-terminal with the A, S, B, and this is the replaced one and we have to. So S tends to A, S, B, we are rewriting. And after that, so we already got this A, B, B, and what we have to do? We have to substitute this S tends to epsilon. So S tends to epsilon, B, B. And after that, finally, we got the input string. So this is one leftmost derivation. Let me draw. So S, this is the root node. And what is the production rules? We have taken A, S, B. And what we have substituted? A, S, B. And here epsilon. So after this one, we will get the input string A, B, B. So this is one leftmost derivation. Left derivation tree. Left derivation tree. And next, for the same, we will take one more. S tends to S, S we will take. And after that, S tends to S. So here only one leftmost derivation we will take. So this S has to be replaced. So what we have to replace? S tends to A, S, B. So S tends to A, S, B. So A, S, B and S. So what in the leftmost derivation, which one we have to replace? So S tends to again A, S, B. So A, S, B, B, S. And here we have to substitute this leftmost. So S tends to epsilon. So A, epsilon, B, B, S. And again we have to replace this S. So S tends to epsilon. So A, B, B, epsilon. So finally we got the input string A, B, B. So for this one we will write the strings. So we will write the derivation tree. So S tends to S, S. So here for instead of S, what we have replaced? A, S, B. And in this one again A, S, B. So again we replace this epsilon. And here also epsilon. So finally what we got? So we got the input string. How to read this input string? A, epsilon, B. So here the input string is what we got. So further, this is also a leftmost derivation. Leftmost derivation tree. So for the same input string, we got the two for the same input string, we have the two leftmost derivations. So, two leftmost derivations. So, we can say that this grammar is also a ambiguity grammar. So, we can say that when we form the two leftmost derivations or two rightmost derivations or two paths trees, we can say that it is a ambiguity. So, ambiguity in the context-free grammar. So, let's check for the another example. And here we have taken the grammar. So, S tends to A, capital being B. So, here let me write the grammar first. So, V, T and P and S. So, for this one, how many non-terminals we have? So, A, B, A. Sorry, again A, B we have. And terminals A, comma, B and epsilon. And here the production rules and S tends to here S, capital. So, starting state is a capital string. So, here we have to derive the string AE. So, first step what we have to do, we have to take the first start symbol. So, we will directly derive the leftmost derivation. So, here A, B, A. So, here we can write. So, if you check for the leftmost derivations, so A, we will write, and after this one, we have to substitute. So, we will substitute this A tends to A, capital A. And after this one, we have to substitute this. We already have the terminal and non-terminal. So, here we have to substitute this terminal with the again A and A, capital A. So, again we have to replace A tends to AA. So, and after this, we already have the AE. So, again, if you replace this A with the epsilon, so A with the epsilon, we will get the input string. And again, we have to move. Why we are moving from left to right? So, this is a left derivation tree, LDT. So, we can say that LDT. So, and here after this one, B tends to epsilon and A tends to epsilon. We have to replace. So, finally what we got? We have the input string. So, input string is AA. So, this is one left derivation tree. And we will form one more left derivation tree for the same input symbol. So, how we have to? So, A, B, A. So, here what we have to replace? First, if you replace A with the epsilon, so this is also a left derivation, LDT. So, and after that, we have to replace B with, so there is no B terminal, so we can replace it with the epsilon. And after that, after moving from left to right, we have only A. So, we require double A. So, we have to replace A with A. And after that, so this already have the terminal and non-terminal. So, here we have to replace this A with terminal or non-terminal. So, finally, after this one, we have to write with epsilon. So, what are the steps involved in this one? A tends to epsilon, after that B tends to epsilon and A tends to A, capital A, and again A tends to A, capital A, and A tends to epsilon. So, these are the substituted values. Finally, what we get? Epsilon, epsilon, A, epsilon. So, what is the input string? After removing the epsilon symbols, AA, what we get. So, this is also one LDT and this is also one LDT. So, for the same context-free grammar, we have the two left derivation tree for the input string. So, this is about the ambiguity in the context-free grammar. And here, we will discuss the topic regular grammar versus context-free grammar. So, there are few differences between the regular grammar and context-free grammar. What are those? We will discuss. So, first one is about, so tuple. So, it is a four tuple notation. So, here the four tuple notation for the context regular grammar. So, regular grammar versus context-free grammar. So, in the four tuple notation, what are the four tuple? Here also, so four tuple. So, four tuple is G is equal to V T, F, P and S. So here also we have the grammar, context-free grammar also having the 4-tuple notation. So V, T, P, comma, S. And here we will derive this V is a non-terminal symbols, and here also V is equal to non-terminal symbols. And terminal symbols. So here terminal symbols. And here T is equal to terminal symbols. And production rules. While coming to the production rules, we have few difference. One is, so here we will write the production rules. S tends to a terminal and S tends to terminal and non-terminal combination. So this is the 2 production rules for the regular grammar. And here when coming to the context-free grammar production rules, so here we will have S tends to terminal and S tends to terminal, non-terminal, and also we can have the one more terminal symbol also. There is a difference. So here this grammar, regular grammar contains terminal and non-terminal, and here in the context-free grammar we can also have the 2 terminals and with the combination of non-terminal. So that is the difference. And this S is the start state, and here also, so S is the start state. So this is about the 4-tuple notation difference for the context-free grammar and regular grammar. And one more difference with this context-free grammar, so we can construct a DFA. So deterministic finite automata. So with this context-free grammar, we can construct a deterministic finite automata. And here with this, so we can construct PDA, push down automata. So with this context-free grammar, we can construct a push down automata. And here with this regular grammar, we can form deterministic finite automata. And here it is not suitable for, so it is not suitable for parsing. And this regular grammar which is not suitable for parsing. And this is suitable for parsing. So with this we can construct a parsing freeze from the context-free grammar. And what is the one more difference? So it is a type 3 grammar. So in the context, in Chomsky hierarchy, so we have a type 3 and type 2 and type 1 and type 0. So this is a Chomsky hierarchy. So this type 3 grammar is nothing but this regular grammar. So this regular grammar is a type 3 grammar. And here when coming to the Chomsky hierarchy, this is the context-free grammar is a type 2 grammar. So type 2 grammar. So with this diagram we can say that type 3 grammar, that is a regular grammar which is a subset of context-free grammar. So what is the one more difference? So regular grammar is a subset of CFG. So context-free grammar. And here what is the difference? So and here with this context-free grammar is a, so context-free grammar is a type 2 language, type 2 grammar. And here it is a every regular grammar is context-free grammar. So here grammar is a regular grammar is a subset of context-free grammar, and here every regular grammar is a context-free grammar. So this is the differences between the regular grammar and context-free grammar. And these are the references where we have taken the examples. And with this, we can end this video. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.